This presentation will be about groundwater arsenic poisoning, especially around the perinatal period. The class is Introduction to Environmental and Occupational Health. This is Group 2. In this presentation, we'll give you the background of the issue, sources of environmental and occupational exposures of arsenic, health impacts, legislation, scientific limitations, and then we'll conclude. Arsenic is an element that naturally occurs in the environment. It is found in air, water, soil, and food, and is commonly used in pesticides, cosmetic products, and other consumer products. As most of these products have extremely low levels of arsenic, it's usually not a concern. However, certain sources such as groundwater can have extremely high levels of arsenic, which pose a threat to the health of humans and other biological organisms. Prior to moving into the health risks of arsenic exposure during pregnancy, let's look at arsenic exposure in the groundwater and how this occurs. Arsenic is naturally found in groundwater and in high amounts poses serious health threats to individuals. Approximately 50 countries, such as parts of India, Bangladesh, China, Mexico, and the United States, are currently consuming water with arsenic levels above the World Health Organization guideline of 10 micrograms per liter. In these areas, there are sometimes other sources of water, such as surface water, which minimizes the need to use the groundwater. However, in some of these locations, groundwater is the only or main source of water. This could be due to natural reasons or due to policies implemented to protect the population from communicable diseases which can be spread through contaminated surface water sources. The World Health Organization states that arsenic is the most significant chemical contaminant in drinking water globally. Arsenic is found both in organic and inorganic forms. The inorganic form is highly toxic, while organic forms, found in seafood, are less harmful. The highly toxic inorganic form is found in drinking water. The main issue discussed during this presentation is arsenic exposure throughout pregnancy. Pregnant women are a high-risk population because not only can the mothers be at risk for adverse outcomes, but in utero exposure also poses health risks to the infant. Previous studies have shown that ingesting arsenic during pregnancy through groundwater poses risks to the mother, including, but not limited to, abdominal pain, vomiting, diarrhea, skin pigmentation changes, and cancer. Research has demonstrated that arsenic exposure also causes low birth weight, low birth size, infant mortality, and a variety of other outcomes in infants. Arsenic is present in more than 200 different minerals in the Earth's crust. Volcanic action is the most important natural source. Man-made sources include arsenic trioxide as a byproduct of metal smelting operations. The world production of arsenic is used in timber treatment, in agricultural chemicals, in glass, pharmaceuticals, and metallic alloys. Replacement of arsenic compounds with the phosphate herbicides has resulted in remobilization of existing arsenic in the contaminated soil. So if arsenic is released into the atmosphere by industrial processes or volcanic activity, it attaches to particles that are dispersed by the wind and then fall back down to the ground. Microbes in the soil and sediment also release substances containing arsenic into the atmosphere. These are converted to other arsenic compounds that settle back under the ground. And then when arsenic is fixed in the soil, it's safe to the environment. However, arsenic can be easily transported to groundwater by arsenic desorption. So that is when phosphate replacement herbicides, phosphate has similar chemical properties and similar dissociation constants with arsenic. When adding phosphate to arsenic soil, phosphate will replace with arsenic, causing the arsenic desorption from the soil. Now, a little bit more in depth about the different health impacts of arsenic. Exposure to arsenic can cause many different health effects that may have an impact on anyone exposed, but some major effects have particular relevance to pregnant women. Some of the general health effects include gastrointestinal problems like emesis, diarrhea, and abdominal pain, hepatic impacts, which include elevated liver enzymes and hepatic necrosis, renal failure can occur, cardiovascular effects, which can include vascular and cardiovascular disease or hypertension, and neurologic issues that may present include neuropathy, encephalopathy, and delays in cognitive development. Different dermal issues are tied to arsenic poisoning, and those include hyperpigmentation, which is darkening of the skin, and hyperkeratosis, which is thickening of the skin. Respiratory irritation may also occur, and arsenic exposure is capable of causing cancer, frequently in the skin, bladder, liver, lungs, and kidneys. With pregnant women, there are additional reproductive effects of arsenic. Arsenic is capable of easily crossing the placenta, especially early in pregnancy, and the ease at which arsenic enters the placenta appears to be a major factor in the severity effects during pregnancy. Arsenic exposure during pregnancy has been tied to low birth weights for infants, as well as spontaneous abortions, stillbirths, neonatal and post-neonatal mortality. Infants born to mothers who were exposed to arsenic during pregnancy have a higher risk of low birth weight due to lower maternal weight gain and because of premature delivery. There is a dose-dependent relationship between maternal exposure to arsenic and infant mortality, meaning that infants born to women exposed to higher concentrations or exposed for longer periods of time have a higher mortality rate. So some legislation that has come out of arsenic exposure. In the USA, in 1975, under the Safe Drinking Water Act, the Environmental Protection Agency determined the national interim primary drinking water regulation levels of arsenic to be 0.05 milligrams per liter, or 50 parts per billion. Throughout the years, many studies reported dose-dependent effects of arsenic in drinking water and skin cancer. In order to prevent new cases and death from cancerous and non-cancerous diseases, the Safe Drinking Water Act directed the EPA to revise arsenic's levels and specified the maximum contaminant levels, MCLs. MCLs are set as close to the health goals as possible, considering cost, benefits, and the ability of the public water systems to detect and remove contaminants using suitable treatment technologies. And then in 2001, the Environmental Protection Agency adopted an even lower standard of MCL, which is 0.01 milligrams per liter, or 10 parts per billion. In South Asia, arsenic contamination of groundwater is now recognized as a major public health concern affecting a large number of people. The contamination in the Ganga-Brahmaputra fluvial plains in India and the Padma-Meghna fluvial plains in Bangladesh demonstrated adverse impacts on human health. The World Health Organization Guidelines for Drinking Water Quality, established in 1993, a provisional guideline of 0.01 milligrams per liter for maximum contaminant levels of arsenic. So there are some factors that lead to national standards differing from the guideline values. In countries such as India and Bangladesh, the permissible limit of arsenic in absence of an alternative water source is 0.05 milligrams per liter. So some of those factors that lead to those national standards differing include a variety of geographical, socioeconomic, dietary, and other concerns affecting potential exposure. So arsenic removal technologies are traditional treatment processes which have been tailored to improve removal of arsenic from drinking water. Although some of the removal processes, such as precipitative processes, adsorption processes, ion exchange processes, and separation or membrane processes may be technically feasible, but their costs may be prohibitive. So for underdeveloped countries, the challenge is finding the means to fund such technologies. So some studies have been done to develop and analyze arsenic contamination and potential issues of environmental justice, but there's not a whole lot of research yet. Two studies highlighted here. The first one on the top left found that higher arsenic levels and higher odds of receiving an MCL, or a maximum contaminant level violation, were most common in community water systems serving predominantly socioeconomically disadvantaged communities. The findings suggested that communities with greater proportions of low socioeconomic status residents not only face disproportionate arsenic exposures, but unequal maximum contaminant level compliance challenges. Then the second study, highlighted at the bottom there, found that there is no evidence that higher socioeconomic households are avoiding areas with arsenic, or that lower socioeconomic groups are disproportionately residing in areas of arsenic. Instead, disparities in exposure may arise from differing rates of protective action, primarily for well testing, water testing for arsenic, and then also for treating and avoiding contaminated water. So, on that note, there is always more knowledge to be gathered. Although there's a large body of evidence to support the relationship between arsenic exposure and negative health outcomes, there's not a lot of research on potential exaggerated effects for environmental justice populations. Because the main means of exposure to arsenic include drinking water, food, and air, there is a clear potential for these exposures to be more present or have a greater impact on people of color or people of lower socioeconomic status, other populations that are at risk of potential environmental justice concerns. Similarly, there's not a lot of research on that limit of 10 micrograms per liter, the drinking water limit, and whether it's effective for pregnant women. So there's some evidence that suggests that even lower levels of arsenic can still lead to adverse health outcomes for pregnant women and fetuses. Little research exists on the lower level arsenic exposures in pregnant women, but more needs to be done and more needs to be investigated so that we can safely establish the limits that will lead to better outcomes for pregnant women exposed to arsenic. So, to wrap up, arsenic poses a serious threat to human health, with exposure affecting many different systems in our bodies. Drinking water is of greatest concern with regards to exposure. Actions to prevent and control arsenic exposure have been developing over recent decades, but remediation and alternate, cleaner sources of water remain challenging, especially in parts of the developing world. A great deal of knowledge exists on arsenic and negative health effects associated with arsenic exposure, and the body of research is constantly growing, but more investigation is needed in order to fully protect many populations at risk.